In this lesson, we are looking into congruent triangle. The word congruent means identical. Unlike in real life, when you use the word identical, like identical twins, in maths, the word congruent has a strict definition, and in fact, we can only prove congruency of triangle using 4 conditions. Okay, so without these 4 conditions, we can't prove they're congruent. Okay, right. So as said, we're going to learn 4 conditions. We're going to prove 2 triangles that are congruent, and we're going to reason logically to achieve the congruency proof. Now that is the part where I call it the Marmite part. Some students love it, some students hate it. Okay, let's have a look. First of all, definitions. The 2 shapes are congruent. As I said, congruent means identical if they are the exact same size and exact same shape. They could be facing different directions, but identical. Like these triangles, they are congruent, they're identical. Even though they're facing different way, we call it different orientation, but they could still be congruent. To prove 2 triangles are congruent, we can use the following 4 conditions. The first one is called SSS. Side, S stands for side, 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 side. Next one, SAS, side, angle, side. Next one is ASA or AAS. So angle, side, angle. That means this side is between 2 angles. Or angle, angle, side. And the last one is RHS, not right hand side. It's called right angle, hypotenuse, and a side. All right. There are so many ways you can do to help you remember these 4 conditions. One way is to sing it.
Ready?
Ready.
Angle side, 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 side. Angle side, angle, angle, angle side. Side, angle side, 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 side. Angle side, angle, angle, angle side.
We are going to deep dive into each condition one by one. Okay, the first condition, as I said, is called SSS, side, 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 is when there are 3 lengths are all equal. Now, time to pull out your plethora colors of highlighters. I know everyone has a full panel, I guess, full range of colors of highlighters. So 3.6. So for example, we have our 3.6 and a 3.6 in here. And then we also have 4.5 and a 4.5. And then a 4.2, linking 4.2. Okay. Next, condition 2 is called SAS. SAS, side, angle, side. So 2 sides plus an angle. Now the angle must be between the 2 sides. So the angle, the A must be in the middle. Otherwise, I have got a lot of students laughing this in the student when I taught them, and then some of the cheeky ones, they would say, "Oh, what happens if you put A in the front?" Well, ASS is not a condition. Okay, so SAS, right? So have a look in here. So for example, the 3.6 and the 3.6, and then the 4.8 and the 4.8, and then we also have the angle here, 40 degree. Oops, the 40 degree. So the angle, you can see, must be between the 2 lengths, 3.6, 4.8. If this 4.8, let's say if this 4.8 was a 4.5, then they won't be identical. And we can't prove it in here. Oh, actually they would, because it's SAS, but we can't use SAS because 4.8, the angle 40 degree must be between 2 sides that are the same length. Okay, correspondingly same length. Condition 3 is, we call it AAS, so angle plus a snack aside, so I might be a bit too hungry when I make the notes, or ASA. So the side could be between two angles like ASA or outside two angles. Now this one, you can see the 6 centimeters, and then we've got two angles, 30 degree, 30 degree, and we have 55 degree, 55 degree. So you can see the two angles, the length is, the side is buried in between the 30 degree and 55 degrees. So that's ASA, angle side angle. But this one, 30 degree, 55, 30 degree, 55, but the 4 is outside the two angles. We call it AAS. Okay, so angle side. Last one is called RHS, right angle, hypotenuse, side angle. Not side angle, side. Remember, hypotenuse is the length opposite to right angle, so that's the hypotenuse. So this is the hypotenuse. So in here you can see, again, they are congruent because they've got right angle, they both got right angle. They both have the same hypotenuse, which is 10 centimeters. And then they also have a side that is equal 8 and 8. So that's how they're equal. Here comes practice question 1. State the condition that these are congruent. So you got 6 questions. See if you can use the correct condition to state they are congruent. Okay, so you can use the this page, or use this one to help you. These 4 conditions to help you. So make sure you use these one of these 5 actually. Okay, so pause the video, have a go at the question. When you're ready for the answer, you can press play. Here are the answers. A is SAS, SSS, ASA, AES, RHS. For question F, slightly trickier because you can see the two angles they give it to you is in different position and different size. So your task is to work out a third missing angle. Once you found out, what you realize is they're all the same. So what you can do is, if you're using 75 and 60 degree, you can say they're ASA because 75, 60, and the 8 in between. Or angle side, 75, 45 degree, and 8 centimeter. Okay, that's a slightly trickier one, I guess. This example, we are moving on from just finding a condition to where we have to logicalize our proof to make a concrete proof on congruency. Oh, it rhymes. Concrete, congruent proof. Anyway, so obviously you have to remember these 4 conditions off by heart because otherwise it would be quite difficult to prove the congruency. Here's a question. PQRS is a kite. Prove that the triangle PQR is congruent to PSR. State the reason for every step. So I would like you to think about, in these 2 triangles, which condition do you think is the answer to it? Now, if your answer is SSS, then that could be correct. If your answer is SAS, it's also correct. If your answer is ASA, AS, or RHS, they're incorrect. So that's why it's quite important you know all of them, that you can do it by elimination, especially the harder ones. With proof, one thing to but to understand is that it will require some prior knowledge of every bits and pieces across the whole maths curriculum. And this one is, well, first of all, you have to understand the property of a kite. In the property of a kite, the opposite angles are the same. Okay, these 2 angles are the same, 105 degree. So you can argue, okay, SAS, they're congruent because SAS, because 7, 7, 105, 105 degrees, 11 centimeters, 11 centimeters. That's what we're going to structure our proof. So SAS. So we're going to aim towards this direction, SAS. So first of all, we'll say because, okay, PQ, we're going to use the big boy symbol in here, because PQ equals PS equals 7 centimeter. So that's your side. Okay, so I guess that's your side. Next, you will say because PQR equals to angle PSR equals 105 degree. Now you have to state the reason here. Every reason you have to say opposite angles in a kite are equal. So that's your angle. So SAS. Oops. And then last one, you have to say QR equals to SR equals 11 centimeters. So SAS. Therefore, PQR is congruent. Now, the mathematical symbol for congruent is equal with a curly line on top. Okay, like a sandwich, like a burger. This is the burger. So curly line and equal to PSR. Now, one little detail is that the order of the letters also matters, because what it means in here, it means PQ is congruent to PS and QR is congruent to SR. Now you can't do you can't do RSP in here because PQ must be corresponding to PS. Okay, and the reason, of course, in bracket SAS. Now, what did I say about SSS? Well, it could be SSS as well. I'm going to show you why. Now, it's SSS, I'm going to use different color, is because PQ, same as PS, obviously, QR, same as SR, but PR, they're also equal because PR is shared. So you can also argue it's SSS. So the reason is because PQ equals to PS equals 7 centimeter. That's your S. QR equals SR equals 11 centimeters. So that's your side. Now, last one, these two, you don't need explanation for it because they're given. But the last one, you have to say PR equals PR because this is shared. The length is shared. Therefore, PQR is congruent to PSR, SSS. All right. So this example, next example looking at is a parallelogram. One thing you must know parallelogram is that the opposite lengths are equal and parallel. Now, parallel means it affects the angle, that you have to record some parallel angles as well. Right. So we have to show that a triangle ABE and triangle DCE are congruent and state the reason of every step. So I would suggest you to draw the triangles first to begin with. The separate two triangles. So A, B, and E, and then C, D, and E. Now, first of all, what we know is AB, we know is equal CD. So we can say because AB equals CD, so that's a side. So what we know is side and a side. Right, what else do we know? We know angles in parallel lines are equal. So the opposite angles, alternate angles are equal. So alternate angles are equal. Think about like this. When you have a parallel lines, these two angles are equal. They're called alternate angles. So you do have to explain why. So you will say angle ABE is equal to angle ECD or DCE because of alternate angles, and that's your angle. So we found our S. So we've got a side, and we've got angle and angle. So what we know is RHS definitely out of the equation, SSS as well. So what we need is SAS or ASA. So we identify one more angle or one more side. Now, if we want to use SAS, because our angle is here, that means we have to prove our BE is same as CE. Now, it'll be quite difficult. It's actually impossible because we don't know if the diagonal are cut in half, if they bisect each other. So therefore, we can't really say BE is same as CE. So that will be impossible. So therefore, our last chance to prove they're congruent is to find one more angle that they're equal. Either this one or that one. Either BAE or BA. Now both are equally fine. So I'm going to give you two options. One, if I want to show BAE is the same, so BAE will be the same as which one? EDC. Again, alternate angle. So we can say either angle BAE BAE equals angle CDE because of alternate angles again. Okay. Or you can say or. Do you know why? Oh, actually, I'm not using red. Or why would this angle be the same as this one? Anyone know? Why would this one be the same as that one? The reason that they're equal is because vertically opposite angles. So you can also say or angle ABE is the same as angle CED because of vertically opposite angles. So this will be another angle. So either way, you are using AES. So therefore, so these two you can so these two or so either the yellow one or the green one. So you can say therefore triangle ABE is congruent to triangle DCE because of AAS. Next, your chance to have a go.
Boring.
I've demonstrated in the previous two examples how to prove congruent triangles. It's your turn to have a go. In the next few questions, practice questions, I would suggest you try them first before hear my explanation, because with proofs, there's no one way that fits all, and that's why a lot of students either love it or hate it. But please have a go first. If you really need help, struggle with it, then you can play the video. So have a go, pause the video, have a go now. When you're ready for the answer, you can press play. So what I see in here is 88, 88, so they're equal. So therefore, angle ABC is equal to angle ADC, which equals 88 degree. And then what we know is angle BAC equals angle ACD equals 47 degree. So now we need one more length because we've got two angles. So two angles, definitely the ASA or AS. We need one more length. Well, we can see AC is shared. So AC equals AC, or you can either say AC is shared, or you can say AC equals AC, bracket shared. So therefore, triangle ABC is congruent to triangle CDA, reason AAS.
Perfect.
Pretty questions are ranked from the easiest to the hardest. So question 2 is sort of the easier ones, and then to question 5 is the hardest. So let's keep the ball rolling. Pause the video, have a go at the question. When you're ready for the answer, you can press play. ABCDE is a regular pentagon. Regular shape means all the lengths are equal. So we know these lengths are all equal. Okay? And also, all the interior angles are same in size. They're equal in size. Prove that triangles ABC, so ABC, and AED are congruent. Well, first of all, we already know because we know regular shapes have equal length. So straight away, we know length of AB equals the length of AE because of regular shape. And then BC equals, now if you don't know which BC should be corresponding to, you look at this, BC, same as ED. Okay, so regular shape again, regular shape. What else? Now, can we say AC, same as AD? Now, it's quite tempting to say they are equal, but that is not a property of a regular shape, so we don't know that. Therefore, we can't use SSS. Okay. Now we've got two lengths, so the only option we've got is SAS. We just need to show one angle is the same, and if you look at the angle must be between two lengths. There's only one option left, which is this one and that one. So why they're the same? Because, well, regular shape, interior angles inside regular pentagon are the same. So angle ABC is the same as angle AED because of interior angle inside interior angles of regular shape or regular polygon. So therefore, triangle ABC is congruent to triangle AED, and the reason will be SAS. Done. So next one, question starts to be a little bit more harder. There's a circle, so pause the video, have a go at the question. When you're ready for the answer, or if you need help, or when you listen to my explanation, you can press play. The diagram shows a circle with center C. The points A and B lie on the circle. AB is a chord. Prove APC and BPC are triangles. Well, of course they're triangle. I mean they're congruent. Sorry. So we can see in here two triangles. First of all, you can see CP is shared. So when two triangles are merged together, look for the length that is common in between. So CP, you can say this time use different way because CP is shared. Okay. Now if you struggle to sort of see two triangles, what you two triangles, what you can do is you can draw two triangles out. Okay, so that's PCA, that's PCB. Now we've proven these two are the same length. Now right angle, so we can say if that's right angle, that's also right angle because add up to 180 degree. So angle CPA equals to angle CPB equals to 90 degree. So that's a right angle. So right angle, just that's what you need, RHS. So in the RHS, what have you fulfilled in here? Which of the two letters have you fulfilled in this condition? CP is not a hypotenuse, it's a side. So you have done a side, you've got the right angle. What you need to show the hypotenuse are equal. Hypotenuse are the CA and the CB. They are equal because they're both radii. They're both radius. Radii, plural form, radii. So it looks like a circle, but there's nothing to do with circle theorem actually. So CA equals to CB because they're both radii. Okay, so therefore APC is congruent to BPC because of RHS. This is the last question of this lesson. If you can do this question without my help, I can tell you are able to do any type of proving congruency question in the exam. So pause the video, have a real go at this question. When you're ready for the answer, or if you really have no clue how to do this, you can play the video. So we're told ABCD and AEFG are two different squares. So squares means all the four lengths are the same, and there's a right angle. Okay. And then this one as well. Now we try not to overcrowd the diagram because otherwise it might affect you how you see the diagram visually. So now what we know is we know that right angle actually. You're right, I shouldn't overcrowd it. So I might just leave one right angle in there. Right, next EAB. So where's EAB? EAB, we need to make a triangle. So we need to try and make a triangle EAB. So join them up. Okay, so what I'll also do is I'll also draw one right here. Now it's quite useful because then you can see it separately. What it's like a little checkbox what you've done to prove the two triangles are equal, are congruent. GAD. So what's GAD? GAD is here. GAD is here. Okay, so another one. So GAD. Right, no, it's quite ugly. Right, but please spare me. Right, so let's have a look what we need to prove. Now we know, first of all, length of AB is the same as length of AD. So AB is same as AD. So because AB is same as AD, that's the because of length of square, length of or the length of square, they're equal. So next, what do we know? We know AB say AG same as AE. Okay, so AG same as AE. Lovely. So AG same as AE because we start with left triangle. AE same as AG. Again, same with length of triangle, length of square. Right, then we need one more. Now, you've got two sides already. So using this four conditions, you can do it by elimination. Two sides. So ASA is definitely out of the equation, same as RHS. So what you need to find is either you need to find one more side that BE equals GD, or you need to find the angle. Now, think about this. First of all, is it possible to prove the two lengths are equal? I think it will be quite difficult. So let's turn our focus on the angle. Now, we know the two angles are right angle. There's something with right angle in there. So EAB, now if you look at EAB, let me use a highlighter. EAB is a right angle plus the small gap angle in here. Oops, don't mean to draw it in highlighter. that little small angle. So it's a right angle plus that small angle. Now what about DAG? Same thing, right angle plus that small angle. Therefore, they're equal. They're equal. So we'll say um, because angle EAB equal the small angle, so angle EAD plus 90 degree, and angle DAG. So what we'll try and do is we'll try and prove these two angles are the same. So angle DAG is also the angle EAD plus 90 degree. So that equals the angle EA. So therefore, angle EAB equals angle DAG. So altogether, therefore, the triangle EAB is congruent to angle GAD because of SAS. Now, this is quite a tricky one.